Hello everyone, welcome back to my YouTube channel. Today we'll be studying about data cleaning. But before that, data collection should be crystal clear. First, we'll discuss a little about data collection, the methods, how to load raw data and all, and then we'll start with data cleaning. So, let's see methods to load raw data. First we'll see from Excel. So how do we do that? First, this statement will be common import numpy as np. This will be common. Then after that you'll write for Excel you'll write df data frame is equal to pandas import pandas as pd df dot read underscore excel sx and your sheet underscore name is equal to sheet 1, let's say sheet 1. Now I'll explain what have we written here. So read underscore excel is used for read and excel. Now dot excel sx is the extension of the file, and sheet means, have you ever seen when we see excel file you get here sheet 1, sheet 2 and a plus sign. These are all different excel sheets in the same file. Try exploring this part. So this is what a sheet. Second is JSON file. So df is equal to pd dot read underscore JSON raw underscore data. Just wait a minute. This part I have to change. Any file name dot JSON. Then now for a nested JSON, this is real world case, you have to use pd dot JSON underscore normalize JSON underscore data. Then this flattens complex API responses, can load specific sheets and handle multiple tabs. Flatten complex API response, handle multiple sheets. Then read CSV we have covered in the previous class. Then df is equal to pd dot read underscore table, then dot txt. These are all methods. This is nothing to. This is everything you have to learn. And there are many other, like we have done till here. Then we have databases, APIs, web scraping, then from HTML table, zip file, log data, pickle files, cloud storage. These are all files and from which you can extract raw data. So I'll not be covering all of them. These are basically syntax that you all have to remember. That's why I was making these. The main is CSV. This is mostly used in exams and all. So remember that one. That's why I covered it in that video. Rest, we'll now study more on data cleaning. Was all about loading the data collection. So now 5 minutes into the lecture, we have done data loading or collection. So now let's see data cleaning part. So data cleaning, why do we do data cleaning? Data cleaning we can do for missing values, invalid entries, then you can have inconsistent values, duplicate record, wrong data type, and many other reasons. So in data cleaning, we have some methods, but in right now we'll only talk about them in short and crisp way, like binning. What is binning? Binning, the purpose is for noise reduction. Normalization is to scale data. Discretization convert continuous to discrete. Smoothing reduce fluctuations. So I'll write them in short. Binning, noise reduction. Then we have normalization. This is for your scaling data. Then discretization, continuous to discrete conversion. Then we have smoothing. This is for reduce fluctuations. Clustering is clustering. Clustering is for data-driven grouping. Then we have ranking is to preserve order. Preserve order. Then you have aggregation is to summarize data. Summarize data. Log transform is for reducing skewness. Reduce skewness. Then we have, this is important, Winsorization. This is for handling your outliers. So these are some methods with their purpose. So method on the LHS and purpose on the RHS. Next, we have some methods. Now we'll discuss them in detail. First, we'll see noise reduction smoothing. Noise reduction smoothing. Noise reduction smoothing is the process of removing random fluctuations from data to highlight patterns. Noise refers to, now what is noise? Noise refers to your random, irrelevant variations in data. The reason is sensor error, human error or mistake, and environmental disturbance, and there could be other reasons. One more we'll write transmission error. Now solution is smoothing. Solution to this is noise reduction is smoothing. Now smoothing is reducing noise. Reducing noise while preserving meaningful pattern such as trend, seasonality, and cycles. Now noise reduction is important. Why? Why? Improve model accuracy, then prevent overfitting, enhance visualization, clarity, stabilize, statistical estimate. Now first we'll see trend component. So let's see. Now overall upward and downward movement data taken is in over a period of years. Up and down over a period of years. Like so this line upward show the upward trend. Then cyclic component repeating up and down. Repeating up and down. It may vary due to interactions of factors influencing economy. Influenced due to factors. Due to factors 2 to 10 years duration. Like in this graph itself, let's say this is the graph. So let's mark. So this part is known as a cycle. Seasonal component upward or downward swing, regular pattern, mostly observed within a year. One year. So let's say we have this graph. This is showing the increase because this is winter. So in winter, the buying of winter clothes increases. Irregular is when it is unsystematic fluctuation. Irregular. So irregular component is erratic, unsystematic, and residual fluctuations. Random variation, we can say, or unforeseen, which you have not even thought of, unforeseen events. Short duration and non-repeating. We can write this short duration and non-repeating. So after this, we'll see some smoothing methods. One is your moving average. So I'll write the topic first. Statistical smoothing methods. So first is your simple moving average. So the formula is f of t plus 1 is equal to a of t plus a of t minus 1 plus a of t to n upon n. So this is the formula. If suppose you want a 3-month simple moving average, so you'll write a of Jan plus a of Feb plus a of March upon 3. Now we can have 5-month, 3-month. So depending on that, the n value will change. Next, suppose let's take an example first because this might not be clear. Let's say we have year sales and moving average of 3 moving. So 1995, 1996, 1997, 1998, 1999. Sales become 20, 24, 22, 26, and 25. This becomes not applicable. So you take the first three because it is 3 moving average. So average of these three, that is 20 plus 24 plus 22 divided by 3. This comes out to be 22. Then the next three, this will come out to be 24, then 24, then we are done because no other combination will be possible. Now after this 26, we don't have a third value, so we will leave there. So NA. Then weighted, for weighted the formula is f of t plus 1 is equal to wt at plus wt1 at minus 1 plus so on till wt to n at to n. So this is for weighting where you'll add weights associated. Weights. The importance, or you can write importance. Then after that we can have exponential smoothing. Now I know this part will not be clear. So when you will open my YouTube channel, you will go under economics. There I have covered these two topics in great detail. So just wait a minute, I'll tell you economics and then I think it is time series. Yeah, time series forecasting. It covers all these two topics, exponential smoothing and moving average. So I'll not be covering exponential smoothing. Please refer to that video. In that video, I've told the formula. I think I've solved one question also. So I think these two topics will be clear from there. Now next, we'll see the next topic, that is binning. Now in binning, first let's see what is binning. Binning is basically to reduce noise by grouping nearby values. Reduce noise by grouping nearby values. You have equal width binning, that all bins are the same width. Then you have equal frequency binning, that each bin contains approximately the same number of data points. So equal width or equal frequency. These two we have to cover. And then after that, there are of three types. I'll just tell the types: bin mean, bin median, and bin boundary. Now let's solve a question on this. So write down a question where you have elements 4, 8, 15, 21, 21, 24, 25, 28, and 34. Now you are told to make bins of equal depth. Bins of equal depth and smooth using mean and boundary. This will be a 2 plus 2 4 marker. So now first of all, what is depth part? Depth part means equal frequency. So now let's create the bins. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we want equal, we know that groups of 3 need to be made. If 1, 2, 3, 4, 6, 7, 8, 9. So here we have 9. 4, 8, 15, 21, 21, 24. Then third bin will be 25, 28, and 34. Then after that, for bin 1 in mean part, what you'll do is you'll take the mean, that is 4 plus 8 plus 15 divided by 3. Similarly, in the other two bins. In the boundaries, you'll take the minimum and maximum value. I'll tell you first. Replace each value with the nearest boundary value of its bin. Suppose you have 21 and 24. Minimum 21, maximum 24. I'll see in this case because this case is better. So 25 and maximum 34. Now 28 is closer to 25 or 34. It is closer to 25. So 25 is the minimum. 28 is closer to 25, so 25. Now minimum and maximum will be there always. So 34. This is by using boundary. So this will be a new bin using bin boundary method. So this is what we had to do today in data cleaning. We did different methods to clean. We also studied about moving average. We studied about different components, noise reduction. So this was all about data cleaning. After this, we'll do with data wrangling. So thank you all. If you like the video, do like, share, subscribe to my channel. If you have any doubts, do mention in the comment section. Bye bye.